Today we're going to be discussing how do you translate words and algebra together, because this really helps you understand what is it that the algebra is actually trying to say. For addition, there's lots of different key phrases that pop up to indicate that what you're wanting to do is add. Plus sum. Sum is the formal mathematical word for the results of an addition problem, increased by, more than, total of, added to. There's lots of different synonyms out there for addition, but anything that sounds like what you're doing is increasing something by just a little bit, that's going to be addition. Subtraction, the one thing you want to be careful about with subtraction is sometimes the language is a little bit more flipped around from what you're expecting. And in particular, subtracted from and less than. We always first list the number we're subtracting and then the number we're subtracting from. So for example, 2 subtracted from x would be x minus 2. Just something to always keep in mind. It might be worth putting into context. So 2 subtracted from x, replace x with a 4. If I said 2 subtracted from 4, you would think 4 minus 2. That should be 2. Keep in mind for multiplication, there's lots of different notations that can be used for that. So we sometimes use the dot, we sometimes put the letters just right next to each other, we sometimes use parentheses in one way or another. What's not technically on there is it would be unconventional, but still okay to do parentheses a times b. And sometimes we do still use that multiplication symbol, that's the little cross. However, the one thing is that does start to look like an X whenever you're talking about algebraic phrases. So be careful about that. For division, there's similarly lots of different symbols. You have kind of the old school division symbol, but we also sometimes use a slash, or we use a fraction, or this is getting at really that long division notation. Notice that's not a root. That would be something else. That's not division. But there are lots of different ways to also depict division. And division has lots of different ways of expressing it, kind of like addition and subtraction. Divided by, quotient of, ratio, divided into is sort of the one that has the numbers flipped around. For multiplication, times and product tend to be the key words, but there's sometimes other sorts of words that come up as well. So if you say specifically twice or 4 times or 3 times or triple, that's again indicating multiplication. And sometimes they might even sort of mix and match it, sort of like this second line here, where we have 4 times indicating the multiplication, but then it also says the sum of x and y. So for the sum of x and y part, we in parentheses have x plus y, and then for the 4 times part, we have the 4 chilling on the outside. If we're talking about raising to a power, keep in mind that's also exponentiation. Typically typed into a keyboard in this fashion, but then you would write it as x squared with the x on the base, the square up top, or x cubed if it's going to be raised to the 3rd power. And sometimes instead of saying raised to the 2nd power, we can explicitly use words like squared or cubed as well. All things to just keep in mind. So let's practice translating these a little bit. So if I have one of the simpler algebraic stories where it just says x, subtract x from 5, what that is indicating is that you're doing 5 minus x, because what you subtract from, that goes first, and then this is what you are subtracting. This next one is a 2-stepper, so I'm going to put one step in parentheses and then do the other step. So for add 4 to x, it's telling me to do that first, so I'm going to do x plus 4. By the commutative property of addition, you also could write 4 plus x. And then for the second step, it says to multiply by 9. So that's where I'm going to put a 9 on the outside of that parentheses to indicate multiplication. I want you to go ahead and pause your video and try the next 3 yourself. So for multiplying x by 2, that would be most conventionally written as 2x. Had you written x times 2 like this, or 2 parentheses x, something like that, that would still be correct. But 2x like this is typically how you would see that written. And then it says as a second step, we're going to add 6. And really, actually, let me differentiate those colors there a little bit just for clarity. For the second part to add 6, I will write down the plus 6 there. For this next one, again, you want to be careful about going in order. So it says multiply x by 7, so I would do 7x. Then subtract 5, so minus 5. And then for the last part, it says raise to the third power. So then I'm going to put this whole thing in parentheses and raise it to the third power. And you need to put it in parentheses because it said raise to the third power was the last step. Go ahead and pause your video and see if you can do these next 2 examples yourself before I go through them. To subtract 7 from x, that would be x minus 7. So that is a little bit backwards from before, because before was subtract x from 5, so the 5 went first. This is subtract 7 from x, so the x goes first. For the next one, multiply x by 9. Okay, so we're going to do 9x, and then subtract 4, so minus 4. For the next one, it says add 6 to x, and that is first, so I'm going to go ahead and put that in parentheses to indicate, hey, in terms of order of operations, do this first. Then it says multiply by 2, so I'm going to go ahead and stick a 2 on the outside. For the last one, the first thing we want to do is multiply x by 3. Then we're going to add 7. Then we're going to raise the entire thing to the second power. So I have to put it all in parentheses and raise it to the second. In order to tell the story of x, we're going to have to work in terms of order of operations. So in terms of order of operations, we would first look inside the parentheses. But before we actually write that, we should look at, well, what in the parentheses would we do first? Multiply x by 3. So that covers the 3x part. That would be the thing that we do first. Next, the next thing in parentheses we would do is subtract 2. That would be the next thing that we would do there. Then, according to this order of operations, we would now do the operation that's just on the outside of the parentheses, which is raise to the third power. That covers the exponent of 3 there. And then finally, as a last step, we will divide by 4. Equivalently, you could have said multiply by 1/4. And again, there are synonyms for all of these operations, but that's the general story of what you would do in this situation. And if we actually plugged in a number for x, that's exactly how you would evaluate it, just to really emphasize that point. So if I plug in, for example, x is 2, and I rewrite that expression, the way I would evaluate it is first doing multiply x by 3, multiply 3 by 2. That gets us 6. Then I would do 6 minus 2, which would get us 4. Then I would take 4th to the third power, which means 4 times 4 times 4, which is 64. Then I would divide 64 by 4, which would give me 16. So knowing the story of the algebraic expression does help you understand order of operations even deeper and how to evaluate algebraic expressions. Oftentimes you are interested in doing this in the context of a word problem. So if, for example, in a word problem, they might be a little bit more practical, and they'll say something like, Desmond is 2 inches taller than Nikki. So if you're translating such a thing, you're going to have to indicate who you want to make a variable and who you want to make an expression in terms of that variable. And I think it's sometimes helpful to go ahead and assign actual values. So if, for example, Nikki were 60 inches, that would mean that Desmond, since he's 2 inches taller, would be 62. So if instead of writing 60, I wrote x or t or whatever it is, then Desmond would be x plus 2, and I would want to define my variable. So x is Nikki's height in inches, and then that would mean that Desmond's height in inches would be x plus 2. Similarly, if we have, spending more than somebody, again, you're going to at least define a variable. In this case, we're going to let the variable be what Juan spent, And then Linda would be that plus 13. And then so after you've actually written those, it's worth doing a little bit of a sanity check. So if, for example, Juan spent $50, then we would expect that Linda would spend $63. And indeed, that's how it's written in this problem, because that is 13 more. And that works whenever you assign 50 to be R, and then 63 would be R plus 13. So we're good. Sometimes they're actually nice and they tell you how to define the variable. So if it's something like Jake studied for Y hours, Julie studied twice as long, great, Julie is 2Y, and they already defined Y is Jake. So if you sometimes have something that's maybe not as straightforward. So it says Mr. Smith and Mr. Stein drove 210 miles. Now, this word problem could be phrased a little bit better, but it's implied that they drove that combined. So I'm going to go ahead and write that word combined. So combined, that's what they drove. Mr. Smith drove Z miles. So the way that I would visualize how to write an expression for Mr. Stein is I would say, okay, well, we have Mr. Smith plus Mr. Stein would be 210 miles. Mr. Smith we already know is Z. Mr. Stein I could even put in a placeholder for now if I wanted, such as Y equals 210. However, I want to write everything in terms of Mr. Smith, so what do? Well, if Z plus Y equals 210, that means Y has to be 210 minus Z, and that's a way to think through. Mr. Stein would be 210 minus Z. Another way that doesn't involve equations so explicitly is you could just also think it's implied, therefore, that Mr. Stein has to, the Mr. Smith's miles subtracted from 210 would have to be Mr. Stein's miles. However you best want to think of it, but oftentimes we do want to write something entirely in terms of one variable. So let's go ahead and practice this a little bit. So if we had something along the lines of Shea bought C candy bars at $1.50 each. Well, C is our variable. And buying them for that each, we want to think through what operation makes sense. So would addition, subtraction, multiplication, or division make more sense? In this case, it would be multiplication. It would be 150 times C. And then we can kind of double check ourselves. So if, for example, she bought 4 candy bars, our expression is saying it would be 1.5 times 4, which is indeed 6, which is what I'm expecting. Had you done addition instead, you would get an answer that wouldn't make any sense. You get like $5.50. That's not the case of how much you would expect to buy. Because keep in mind that repeated addition is multiplication, which is what we're doing here. For the next one, Thomas bought X movie tickets for $7.50 and Y bags of popcorn for $5. Go ahead and pause this video and see if you can write this one yourself. So that would be $7.50 times X plus $5 times Y. That would give you the total amounts that Thomas spent that day. So Sarah studied for 4X hours. Julie studied for 2x more. Here, what you would be doing is I actually think I have a bit of a typo in this and what I meant to write down. But in the way that it's written, what it would literally be is that Sarah would have studied 4x. Julie would have studied 4x plus 2x. That's actually the way that it's written, as it's already defined. Sarah studied 4x, Julie studied 2x more. I think another variation of this problem that you might see is something along the lines of perhaps Sarah studied for 4 times as many hours as Tommy. Julie studied for 2 more hours than Tommy. So with this new problem, let's think through how that would look. So in this case, Tommy's sort of the reference point, so we're going to make him T hours. That would mean that Sarah would study, since it says 4 times as many, it would be 4 T hours. While Julie, since I just said 2 more hours, that's indicating addition instead of multiplication, so that would be T plus 2, for example. Let's go ahead and take a look at the next one. Zeri is 18 inches shorter than Bella. Bella is Z inches. So for this one, 18 inches shorter than, that would be Z minus 18. And this is, again, a good place to do a quick sanity check. If Bella were, for example, 50 inches, I would get 50 minus 18 is 32 for Zari. And had you written it the other way around, then you would have gotten an answer that didn't make sense, because you would have gotten that Zari is taller, or perhaps even that Zari is negative inches. For the next one, C calories per cookie, N cookies eaten. For total calories, that would be N times C, or perhaps just written as NC. Tax problems are also pretty common, and they require a strong understanding not only of how to translate algebraic expressions, but also how to work with decimals and percents. So there's a couple different ways to approach it. If you're going to be having a tax or a tip, the big key is you're going to want to add on that additional tax or tips owed to that base cost. Versus a discount, you're going to want to subtract that from. So let's take a look a very concrete example of that with actual numbers before diving in here. Let's say an item costs $100 and you're doing a 20% tip on that. Well, what you would do to find that out is you would still have the $100 you got to spend, but then you would add 100 times 20% as a decimal is 0.2 for a total spent of $120. Versus if you had a 20% discount, the way that would look instead is you would take 100 minus 100 times 0.2, which would give you a total of $80. So you want to keep that in mind. So here, if we have a sales tax of 9.1, the way that we're going to figure out that total cost of the item is we first want to express that we have the item itself, which is X. And then we want to add on to that item the amount we have to pay in sales tax, which would be 9.1% as a decimal, which is 0.091. If you forgot how to do that, remember decimals. Remember percents by definition are fractions out of 100, so you can do 9.1 divided by 100 in order to figure that out, times the cost of your item. Now what we can do from here is, this is a little bit previewing the next section, combine like terms. Since both of these are x's, and this x secretly has a 1 in front, we're going to do 1x plus 0.019x's to get us 1.091x as our final expression. Sort of similarly, if we have a 40% sale on an item costing x, well, then you would have x minus the amount that it's discounted. So 40% as a decimal is 0.4. 1x minus 0.4x's leaves us with 0.6x is the final amount that we have to spend. For the next one, this is just wanting to know what the next year is going to look like. Technically, if you were going to do an expression about every year going forward, that would look a little bit different. But just for the immediate next year, there's the current amount that the expenses was, which was X, but then we're going to add, because it says rise, 0.04x, because 4% as a decimal is 0.04. Now again, we can add like terms, 1.04x as our final answer. Go ahead and try this next one yourself before I go through it. So if your meal cost X dollars, then you have to add 0.15 times X to that meal, because 15% as a decimal is 0.015. Oh, it was 0.15, sorry. 0.15, what I have written. I think I said it backwards. Then you combine like terms. X plus 0.15x would give you 1.15 x's. Because remember, all of these x's that are chilling by themselves do indeed secretly have a 1 right in front of them.